Today we are learning how to graph logarithm functions. So we're going to kind of walk through it like we do with any other function we've had this year. So the logarithm equation is y equals a log base b of x minus h plus k. And our parent function is just log of x, and that means log base 10 of x. That's always assumed to be 10 if you don't have to put anything there. Our a values, just like normal, it can stretch, it can compress, and it can reflect the graph. The b value, if it is greater than 1, it is an increase. If it is between 0 and 1, it is a decrease. H moves the graph left or right, just like normal. And remember, that's attached to your x value. It lies to you, so it's the opposite sign. And it tells you where the asymptote crosses the x-axis. And k still moves the graph up or down. Now, if you're thinking about a logarithm graph, it is basically the inverse of the exponential graph that we just finished doing in our last unit. So if you can think of it that way, it's the inverse, which means it has, for every xy, it's now reversed. It's the x values are the y values, the y values are the x values. So we have parent functions for logs. So we have, you can see we can compare y equals a to the x, that's in red, and y equals log base a to the x, that's in green. And you can see it reflects across that diagonal asymptote around that goes through the origin. Log y equals e to the x, that's Euler's number. You can see that one, and then that inverse is y equals the natural log of x, the ln. ln of x is the natural log, and I talk about that on another paper. Y equals 10 to the x equals log of x. Y equals log of x, and you can see if you folded all the graphs along the asymptote, they would be matching up. So for logs, the domain is x greater than our h value, whatever we shift. And our range is all reals. So whereas with exponentials, the domain was all reals, and the range was y greater than or less than to k, depending on which way the graph opened. Now it goes opposite. So exponential functions, they had a horizontal asymptote. But logarithmic functions have a vertical asymptote. So you can see they're basically opposite in every way. So here's the first page with the terminology for graphing logarithms. Now let's flip it over and we're going to do some examples. So when we're graphing by hand, don't forget to label A, B, H, and K. Make sure you know all those values. Identify your asymptote and draw it. This is your x value, vertical asymptote. Sorry, it's your h value. I don't know why I said x. It's your h value. So if you look, the steps are very similar to how we graphed exponentials, right? The 2 points, now the points are b1 and 1, 0, rather than 0, 1, and 1b. And b is the base of our equation. the new y values, it's y times a plus k, and new x is still x plus h. And then we connect the points. All right. So now the asymptote, it is attached to this. So we can see that is x equals 1. So we want to graph that first. And then we know that that shifts right 1. I always like to do transformations first. Our a value, there's none, nothing out in front. And our k value is up 2. So now we put our b value in here, so that's a 3. And so we have to find our new x's. So in each case, we'll just add 1. So 1 plus 1 is 2, 3 plus 1 is 4. For our new y values, we need to multiply by a, but a is just 1, so that doesn't change either of these. And then we add 2, so 0 plus 2 is 2, and 1 plus 2 is 3. So we want to plot those 2 points, 2, 2, and 4, 3. And just like before, our critical point is the top one, 2, 2, and we'll graph it. It's going to look like this. And so then when we list our domain is x greater than 1, and our range is all reals. So hopefully it's easier to graph this time around since we've already had to do it with exponential functions. So it should seem like you can get it a little quicker, I think. I think you'll get it a little quicker this time. All right, so number 2, y equals log base 1/2 of x plus 3. So remember, our asymptote goes with this. So x plus 3 means it is left 3. So that means our asymptote is x equals -3. So we're going to put that in first. Always jot the asymptote first. Excuse me. Okay, so now let's look at the other transformations. There are, once again, no a value, so that's none. And we have no k value. So we're making it easy on ourselves. All right, so what goes in B is that 1/2, the base. And we know our transformation left 3, so we move each of these x values, the 1 and the 1/2, to the left 3. So that would be -2 and -2.5. And our y values are going to be unchanged because we have an a value of 1 and no k value. So it's multiplying by 1. So the y values stay exactly where they're at. And so that means our critical point is -2, 0. So we're going to plot -2, 0 and -2.5, 1 right there. And so we can see when we graph that, it's coming this way. And so it's getting smaller and smaller. So that is because our base is 1/2. So when our base is between 0 and 1, we know the graph is decreasing. So we can see it's decreasing here. Our domain, x greater than -3. And our range is still all reals. So that's what's nice about these is if you can remember the range is always all reals for logarithmic functions, and the domain is always all reals for exponential functions. All right, the last one. So this says f of x equals 3 log of x. So you need to remember when we have nothing listed here, that means it is 10. So I'm going to put that in there so we don't forget. Log base 10 of x is kind of the go-to because we deal with a base 10 number system, generally speaking. All right, so our asymptote, there's no h value, so it doesn't move. X equals 0. And I'm going to just plot that right along the y-axis. Okay. So when we are looking at our transformations, we just have the 3 in front. So it's stretched by 3. No h, no k. Okay. You would think that should make this pretty simple. So now our h values, our x values, excuse me, don't move because we didn't shift left or right. And our new y values, we just multiply by 3. So 0 times 3 is still 0. 1 times 3, though, is now 3. And our critical point is at 1, 0. So let's see. We have the point at 1, 0 and 10, 3. And I'm going to graph that. So it's going to be here. So it's going to look like that. And we would say our domain is x greater than 0, and our range is all real numbers. So hopefully that helps you understand logarithms. If you forget, just remember that they are the inverse of exponential functions.